Hello everyone, my name is Sriram, and this is my software engineering web-based system class. Course number is 6 CS6320, and this is my project. It is a various approach for optimal performance evaluation of e-commerce web application using queuing network. And now I'm going to give you a brief introduction. So I'm going to start. What is e-commerce? E-commerce is a very successful trading business in product or service using computer networks such as internet. So the technology of e-commerce handles, what are the technology e-commerce handles are mobile commerce, electronic fund transfer, supply chain management, online banking, online transaction, etc. So it covers a wide variety of business. So why web application in e-commerce? By using a web application tool, the it can maximize the functionality, power, and flexibility of an e-commerce. So for this web application tool, I'm going to use a method called queuing network model. So what basically queuing network model will do, it will evaluate the performance of this web application, and it will give you a output result, a performance of the web application. And it will optimize the performance, and it will give the accuracy for response time and throughput. uh, so now I'm going to tell you the concept of queuing network. So what is queuing network? So the base concept of queuing network is to analyze and design and to evaluate the performance of a job. A job can be anything. It can be a software model, it can be a web application, it can be any model object, and it will evaluate. uh, the evaluation will be based upon the utilization, the resident time, the queue length, and the throughput. So by using this queuing network model, a performance evaluation of a web application or a software model or anything will be like 5 to 10% accurate for utilization of throughput, and 10 to 30% for the response time. So I'm going to tell you the basic structure of a queuing model. So uh, so this is the diagrammatic description of basic structure of a queuing network model. So you have your, like, these are the input source. The input source are nothing but the customers who are coming in the queue and waiting for the servers to get served actually. And this is the queuing system actually. So in the queuing system you have two things, one is queue and one is service mechanism. So what is a queue discipline? So queue discipline is like a um, member of queue are selected for services. So it is based upon it has some criteria, and according to it it works. So the criteria is like first come first serve. So there is a normal criteria used for this queue discipline, and it has a service mechanism. So the service mechanism consists of one or more service facilities. Each of them contains one or more parallel service channels. They are called servers, and the customer enters on one parallel service channel and it's served by the server. Most elementary model assume or one service facility with either one or finite number of servers. Service time is usually defined by a probability distribution, and These are the terminology and notation for the queuing theory. So state of system is number of customers in the queue. Queue length is number of customers waiting for the service to be begun. So all this notations n of t, pn of t, s, uh, lambda n, nu n, and phi is equal to lambda by s mu. So everything is like based upon the uh, customers in a queue, and customers waiting to be served, and the service the service servers are served. So everything based upon this, all these notations are. And this is the relation between load, workload, load balance, all. So here you can see how uh, the load and workload have been uh, demonstrated. So this is the service, this is the formula for mean service time. So W is equal to WQ plus mu by 1. This mu by 1 is inversely proportional to the expected service time. And I can give you an example problem. Suppose if a customer arrives every 10 minutes on average, so then what is the arrival rate per minute? So here the lambda is like one customer for every 10 minutes. So then the arrival time will be 0.10 customers for a minute. That is like 6 customers for an hour. And the the inter-arrival time between the customers is 1 by lambda. So the service time taken for 30 minutes on average is like mu is equal to 1 customer for 30 minutes, means, and it is like 0.0333 customers for a minute, or 2 customers for an hour. This is the service time. And you can see the calculation for utilization. So the utilization is like, if lambda is equal to 6 customers per hour, then mu is equal to 2 customers for an per hour, then utilization is equal to phi is equal to lambda by s mu. So s is the number of servers actually here. So number of servers, let be 1, then p is equal to lambda by mu, that is 6 by 2 is equal to 3. So utilization is greater than 1, so the steady state will never reach, and the queue length will increase to infinite in a long run. So if again, if there are 3 servers, the utilization is equal to 1, it may or may not be reached. It will be unstable state. It will reach the steady state, or it may not reach the steady state. But if the server is like 4, the utilization will be less than 1, and the queue will reach steady state, and the length will be finite. The queue length will be finite. So go to home page. So here you have a types of queuing networks. So in queuing networks there are like 2 types. They are like basic types. So one is like single service center, and one is like multiple service center. So if you see in the single service center, it has like 2 parameters. One is like workload intensity. One is like the rate at which the customer arrives, and second is like the uh, average service requirement of a customer. So the workload intensity identifies the rate at which the customer arrives, and the service demand identifies the average service requirement of a customer. So these are the 2 parameters for a single service center. And if you observe the diagram, The customer arrives in a queue, and it customer enters in a service center, and service center will serve a customer one by one. And after serving, so after customer have been served, the served customers, they will be departing from the other side. That's the departing customers. And if you see the utilization, resident time, queue length, and throughput for this single service center, it is like the utilization will be like 0.625. This is like some random customers uh, in a queue, some random server have been used. So for this thing, the utilization is like 0.65, the resident time is 3.35, and the queue length is 1.67. The throughput is like 0.65 customers for a second, point point 0.5 customers for a second. So if you come down, you can see the graph analysis, performance measurement for a single service center using utilization and resident time value. So for utilization 0 to 1 or 0 to zero point 0.8, the graph is like it keeps on increasing. This is like it it may never reach to the limit to finite state. The queue length won't be a finite state. It goes to infinite state. Similarly, the resident time will be higher actually. It won't be uh, it won't come to the finite state. And if you see single service center for a queue length and throughput, again it's same. It reaches to the maximum. It goes to the finite. If you observe both queue length and throughput. Um, and the attributes for a queuing network or a queuing network model have a quality set of attributes. So the first attribute, it says that rate at which a customer arrives is only one three available means to describe workload intensity. Example like a transaction process workload. It can be interactive. It can be jobs, and it can be transaction. It can be based upon these things. And the second attribute approach is a state the number of customers in the model. So like the number of customers waiting for in the queue for the servers to be served. So that is a second attribute. So it can be batch workload. Example is batch workload. And the third attribute approach says the state the number of customers and the average time for each customers. It's like spends thinking, which means like the interactive time, the interaction. It takes the time between one customer to the other customer. So example is interactive workload. And queuing parameterization. So the queuing parameterization network is made upon an assumption. So like now, if let's say if you're assuming to calculate a CPU demand of a customer in a queuing network model for a current system. So here we observe two operations. One is the number of seconds the CPU was busy, and the number of user requests that were proceeded. So user required in the sense like the transaction, the interactions, or the job. So then they divide the busy time by number of requests completion to determine the average number of seconds of the CPU service attribute to each request. And here you can see modification analysis, and it has two effects. One is like primary and one is secondary. Based upon these two effects, the parameter will be changing uh, for a uh, queuing queuing network model. And in the evaluation phase, you can see two approaches. One is like calculating the bonds on performance measure, and one is evaluating the value of performance measure. and for algorithm for performing the evaluation should be extremely efficient, especially the running time. And the algorithm should establish, always it should establish from lowest level of queuing network modeling to a higher level in a software package. And here I have given different approaches to optimal the performance for e-commerce web application using queuing networks. So this base concept of queuing model is to analyze and evaluate improvement performance of a complex system behavior. So e-commerce on web system is one of the complex system behavior, and there are different queuing model approaches addresses in many studies given to resolve this complex system behavior using queuing network. So some of them are, so we are going to see some of them. So first one is like Almeida is a scholar, and what he has given is like he has addressed the queuing network in his paper, and it is like a model that identifies optimal resource allocation by a provider's maximizing revenue and satisfying customers QoS is quality, uh, it is quality service constraint, and minimizing the resource usage cost. And it has two tightly interrelated problems. One is like short-term resource allocation, and one is like long-term capacity planning. So in this, so for this problem, they use queuing network model to address the resource management problem in a autonomic service oriented architecture. So the work evaluated the algorithm execution time and the runtime, and they experimented with the various model parameters. So they experimented fetches them in two ways. One is like the large problem size is resolved in 15 seconds, and another one optimization model can be sublet and total cost serving for a provider as much as 39%. So it reduces the uh, resource usage cost to 39%. So the second approach is like Zhang Liu. So he addressed a queuing networks in his paper, where like he used a method for maximizing the profit in a general class of e-commerce environment. So they use a generalized process sharing GPS closed queuing model with a multi-classes for each servers, and formulate a service legal agreement between the service provider and the client. But there is a delay in the class of distribution. So as the delay was experienced by the customers in the business, so they result in a loss of revenue in the business. So they construct a optimization problem based on the queuing theoretic formulas, and they came up with the result that they solve this problem via fixed iteration point. This minimizes the profit service legal agreement in an e-commerce environment. Then Udgankar have proposed uh, a queuing network model in its application. So it says like novel dynamic provisioning technique for multi-tier internet application. So this is to determine how many resources are to locate to each tier of application. So the combination of predictivity and reactivity method determines where the to provide these resources both on large and small time scales. So these authors used a method called GG1 based technique. It is like multiple server with multiple queues with one server based technique. It's an open queuing where it doubles the three-tier application workload. I can give you an example for this thing. So if let's take a flash crowd. A crowd of users on a computer network appears and disappears in a flash. So the experimenter have been resulted that maintained response time targets and overhead of switching servers across application is reduced from minutes to less than a second. Another scholar named Boney, so he gave a queuing network approach in his application. It's like a adaptive load balancing strategy called simulated annealing load spreading an algorithm. It satisfied a different customers' priority, some like default and premium customers. The service are handled in a time given without the server executing service logic. So the average waiting time is derived through the standard queuing theory. So the experiment has resulted that the SLSA simulated annealing load spreading algorithm has the ability to dynamically adapt its load balancing strategy. So all these scholars have have addressed the queuing network as a solution for their problems, and it paid them intensively good as a result. Uh, so so in conclusion, my opinion is like for the web application e-commerce, by using this queuing network model, it will give a performance of more than 5 to 10 percentage than any other web application tool you are using. So it will yield great uh, a better solution than the other web application tool. And here is the annotated bibliography. So here from these website and from these papers I have taken this particular article and I have presented. So thank you for watching this video. I hope it is useful uh, for you guys. Thank you.